Hey guys, welcome to Stat 441 at Virginia Commonwealth University. This lecture will cover chapter 3 and we're talking about probability theory in this chapter. Okay. Here is the objective of this chapter. So we present the introduction to the theory of probability, and we will suggest how it's connected to drawing statistical inference. So the use of probability for drawing statistical inference is what we are trying to understand in this chapter. There are multiple roles that probability plays in statistics. So first of all, let's think of drawing a statistical inference. So we draw a sample from the population and then gather information from the sample to predict or draw an inference about the population. But a sample will rarely tell an accurate story of the population. Okay, there is always some margin of error present in the data. For example, you are trying to estimate the proportion of people in favor of a particular political candidate or some consumer product. So what you see in the sample will not always translate to what you see in the population. There will be some error present. So what probability helps us do is it helps us measure the amount of uncertainty that we have in the estimate. And this is called the reliability of an inference. So it plays a major role in statistical inference. So to do that, we first need to understand some basics of probability. Another use is measure of uncertainty associated with events. So let's say you are a daily newscast and you want to report the probability of rain on a given day. Okay, and you say it's 20%. So this statement tells us the uncertainty associated with rain on that day, and the likelihood of occurrence is 20%. So it does give us a numerical measure of uncertainty of events. Okay. Then probability will also play a role in decision making. Let's say you are an oil exploration company and your past records show that 10 out of 10 previous drillings all resulted in dry wells. So what would you do if you are drilling a next well? Do you think there is a more than 50% chance of hitting all? Should you invest in the company? So these are the things which will help us make a informed decision. Okay, so let's start with some basic definitions and the notations that we will use for probability. Starting with the first idea, the experiment. So experiment will be the process which we will use to obtain and generate observations. So let's say we toss a coin and we record the face up. So the experiment here is tossing the coin. And the face up, it will be either a heads or a tails. That is a basic outcome of an experiment. A basic outcome is called a simple event, and it is an outcome which cannot be decomposed further. So for the coin experiment, the outcomes are getting heads or getting tails. Okay, looking at another simple experiment. This time we are tossing a die and observing the face of the die. So in this case, there are 6 possible outcomes. We can either get a 1, 2, 3, 4, 5, or 6. These are simple events because they cannot be decomposed further. Here is the notation that we will use to write out the collection of all possible simple events of an experiment. It's called a sample space. It will be denoted by the letter S. So for the coin flipping experiment, our sample space is H and T with the curly brackets. Let's say we have another experiment where we are flipping 2 coins consecutively. In that case, the sample space will be HH, HT, TH, and TT. Consider the experiment where we are tossing a die. Again, we saw that earlier. The sample space is 1, 2, 3, 4, 5, or 6. Okay, now the sample space that we write out, it depends on what we are measuring. It's not just what the experiment is, it also depends on what we want to measure. So let's say for the two dice experiment, tossing two dice, instead of just looking at the numbers, we are interested in the sum of the two numbers. Okay, so in that case, what is the sample space? So think of what are the possible sum for two numbers on a dice. So we can start with 1 1, 1 2, 1 3, so on and so forth, all the way up to 6 and 6. So these are the possible outcomes. If an outcome repeats, we don't write it twice, we just state it once. So this is the sum of two dice. Now let's say for the same experiment, we are tossing two dice, but this time we are noting the product of the two face. Okay, so these are the possible outcomes for the product of the two case. Again, you can think of 1 times 2, 1 times 3, 1 times 4, 1 times 5, 1 times 6, and then start with 2 times 2, 2 times 3. Again, you don't repeat. So 2 times 1 will give you 2, which is already there. 2 times 2 will give you 4, which is already there. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. Then you start with 3 and you state all the possible numbers if we toss two dice and then take the product of the two. So this is our sample space. Okay, here's a look at what we are doing in the two dice experiments. If you look at this picture, we are finding the sum of the two dice. So let's look at this. 1 and 1 will give us a sum of 2. For a sum of 3, it could be 1, 2 or 2, 1. Okay, then for let's say 8, these are the possible combination: 2, 6, 6, 2, 3, 5, 5, 3, and 4, 4. But the outcomes that we are interested in are the numbers in blue. Those are the values of the sum of the two dice, although there are various combinations that give us the same number. Let's look at another example here. This time we have an experiment of first flipping a coin. Then if we get heads, then we flip the coin again. But if we get tails, then we toss a die. So it's in 2 steps. So what will be the sample space of this experiment? So this is the sample space. We start with the heads. If we get heads, then we toss the coin again. We get another heads or tails. So H, 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 T, if we get heads on the first coin. And then if we get tail on the first coin, then we toss a die. So our possible outcomes will be T1, T2, T3, T4, T5, and T6. These type of experiments, it's another way to visualize it. We can make a tree diagram. This is what the tree diagram will look for this experiment. So remember, we are flipping a coin first. If we get heads, then we flip the coin again. If we get tails, we will toss a die. So let's look at this example. So this is the first coin. If we get heads, we toss the coin again. So we get heads and tails. If we get tails, then we have the 6 possible outcomes. Drawing tree diagrams will be helpful in computing probabilities, and we will be using the tree diagram in some later examples. Okay. The next idea is event. So we've seen a simple event. It's a basic outcome of the experiment. We cannot break it further, but an event is a subset of the sample space. So basically an event consists of some simple events from the experiment. So let's look at the example. We have the example here. Consider the experiment of tossing 2 coins. The sample space is HH, HT, TH, and TT. Let's consider an event that at least one head appears. So this is a subset of the sample space. And let's look at the elements where at least one head appears. So one head, this one, HH, one head, HT, TH, TT doesn't have any head. So these 3 elements will be our event A. Let's look at another event B. this event has exactly one head. So again, let's look at these elements here. Exactly one head is HT and TH. So our event B is HT and TH. So usually events are denoted by simple alphabets. Sample space is S, and simple events can be denoted using the letter E. Okay, so let's put it together. So probability of an event is the number that measures the likelihood that that event will occur when an experiment is performed. So that event could be a simple event, or it could be an event which is a combination of some simple events. Usually the probability will be approximated as a proportion of times that event occurs if that experiment was repeated over a large number of times. The simple event E is denoted by the letter E, and the probability of E is denoted as P for probability, and then within parentheses we have letter E. We can do the same thing for any event, probability of A, probability of the sample space. So the letter P represents the probability. Okay. Here are two basic rules for assigning probabilities of simple events. First of all, any probability of a simple event or any event otherwise will be a number between 0 and 1. It cannot be more than 1. It cannot be less than 0. You cannot have a negative probability. For simple events, since a sample space is a combination of all possible simple events, the sum of probability of simple events in a sample space has to be equal 1. Okay, so that's two basic rules of probability that will be used throughout. Let's look at another example and then find the probability of an event A. So we know for a simple event, the probability can be calculated as a proportion of the total number of outcomes. For a probability of event A, we will add the probabilities of the simple events that are part of that event A. So let's look at an example. Consider the experiment here of tossing two coins. This has four possible outcomes: H, H, HT, TH, and TT. Now, since these are fair coins, we are assuming fair coins, each of these outcomes is equally likely. So we have a probability of 1/4 for each of these simple events. You can see the sum is 1. Four possible outcomes, equally likely, the sum is equal to 1. Okay, now let's define an event A which is observing exactly one head. We have seen this before. It will be HT and TH. So the probability of A will be the sum of these simple events. 1/4 plus 1/4 gives 1/2. Probability of observing exactly one head is 1/2. And the other event B is observing at least one head. And we saw it had the three simple events here. So we add the individual probabilities, 1/4 plus 1/4 plus 1/4, it gives 3/4. Okay, so these are this is the basic setup: experiment, simple events, and then defining an event and writing the probability. Please watch the next video for more information on probability. Thank you for watching.